Okay, ji, Bismillah ar-Rahman Rahim. In the previous lecture, we were discussing the different types of internet service providers, and we were seeing basically the whole purpose of discussing internet service providers was that we noticed that there is no as such structure of the internet. So basically, the internet grew into this gigantic network that we are using right now, and it is providing us with global communication, but at the same time there is no as such defined structure to how the internet is growing. And in terms of structure, if there is any terms of structure, if there is any terms of hierarchy, the only place we can see that is with internet service providers. So we discussed that in the previous lectures. So if you want to go through that again, you can go visit the previous lecture. Now let's start to discuss the role of routers and how the original network that we studied, that we used to have before the advent of the internet, the public switch telephone network. So we'll be looking into these details today. Okay, so let's understand the role of a router. As mentioned before, we are in the environment of a packet switch network. So that means is that a data is divided into small chunks of all data transmission that we have to carry out over the network is divided into small equal sized chunks known as packets. Each packet has its own header information, and based on this header information it is relayed from source to destination. Now, the basic principle of packet switch network is, we're not going into too much detail, but the basic principle of the packet switch network is that each packet travels on its own path from its source to its destination. And each packet is therefore assembled at the intended destination. Now, how does the packet reach the intended destination? Well, of course, this is where the role of IP addresses comes in. Each packet comes equipped with a header, and the header is mentioning the IP addresses of the source and the destination. So based on that IP address, each packet is basically reaching the destination. Of course, since each packet is arriving on different paths, it means that it will take different times, arrival times at the destination. And because the arrival time of each packet has changed, it means then most probably the order of data has also changed. So that's why we have sequence numbers maintained for each packet, so that the receiving computer can rearrange the data into its original form, making sure that the information, there is no loss of information. Now, this is the overall purpose or and working of the packet switch network. And the packet switch network is the transmission network that is dominating our internet use today. But the main component that allows for packets to be reaching the source to the destination is a a huge number of routers in between are the source and the destination. Now, basically, when I send a packet from my computer to, say, a computer in Japan or wherever, it, now that packet reaches that computer in say in North America. It reaches there, but we don't realize that in between there are numerous routers that basically receive a packet from my computer. They determine where it's supposed to be going based on the IP address that's mentioned of the packet, and is forwarded to the next router. And the next router does the exact same thing. It observes the IP address and decides which router should it be forwarded to. And eventually it hops from router to router, eventually reaching the destination. So what that means is that the router plays a very important role in our internet communications today. In fact, if we if we go back to the basic topologies of networks, the basic topology of the one of the topologies that we studied back then was the mesh topology, and the mesh topology is a topology that cannot be basically implemented in a wired network. But since, if we look at it, actually mesh topology is the topology that we're using right now for our internet communications. So what it means is that since I cannot apply mesh topology in a wired network, but I'm using that complex topology for the most complex network known to mankind, which is the internet right now. And the reason we're doing that is because everything is connected wirelessly. And the mesh of routers basically allow for communication around the globe. So we have so many routers, and all routers are directly connected to each other router, hence the term mesh topology. And thereby, each packet is capable of reaching every other computer almost seamlessly. Internet can be seen as a series of connections that can be used to carry out most of the traffic. These connections comprise of undersea fiber optics connected together via nodes forming a mesh structure. At these nodes is a device known as a router. So as you can, if you remember in the previous lecture, we discussed what this submarine cable map looks like. And essentially, if you look at it, there is a wide, there's a huge map of under submarine cables, these fiber optic cables. And we also studied that it is basically your tier 1 internet service provider that is maintaining and installing these submarine cables. So as far as the purpose of the tier 1 internet service provider goes, the tier 1 internet service provider is primarily responsible for establishing global networks. And this can be seen here, as all land bodies are basically connected through these underground submarine cables. But the important thing is, not everywhere data is sent through these cables. At the end of these cables, there's this node that is capable of transferring data wirelessly, and that node is known as the router. These routers not only provide general mesh of internet communication, but also connectivity within an internet service provider network. So if we look at an internet service provider, may it be a tier 1 or tier 2 or tier 3, their communication within their network alone is also carried out through routers. So if I'm accessing internet service provider, a tier 3 internet service provider, that internet service provider is spread across a wide area. And of course, that wide area is mostly going to be wirelessly. Now, how am I communicating amongst other nodes in that wireless environment? Of course, through routers. Each router is connected to several other routers, and its function, apart from connectivity, is also to find the best possible route for a transmission. More details of working the router will be discussed later in this course. Now, one interesting thing here is that what is a router, by the way? A router, you can say that it looks like is some sort of connecting device that allows two different components in a network to connect together. That's okay, that's agreed. It's sort of like how a switch or a hub should work in a star topology. But the thing is, router is a much more advanced device than switch or a hub. Hub in fact is the most primitive of these devices. Hub is a dumb device. Hub is not capable of distinguishing between a specific intended recipient. In fact, hub transmits data to all connected devices. Whereas a switch in a star topology is capable of distinguishing individual devices and only communicating with the intended recipient, leaving out everyone else. So switch is a smarter device than hub. But the router in a sense is just like a computer. Why is it called is just like a computer? Because a router does a lot of processing. What type of processing? Well, importantly, router is capable of deciding, making decisions based on the current situation of the network. The router not only forwards packets to their intended destination, but it also decides what is the best possible route from this current router to its intended destination. Each router is taking that decision. And because of these decisions, the path that is chosen from the source and the destination, it is the most optimal one. Now, by most optimal, it doesn't mean that it is the shortest path. Now, if you consider the example of, say, you want to travel to, say, your school. Now, you have two options for going to your school. One option is going from your inner city routes between, tight lanes and your traffic signals. It's very short, but that is one possibility of reaching your school. Another possibility of reaching your school is via some highway, some connecting ring road or motorway. And that will cause your traveling to be a little longer, but you will reach your destination, your school, in a much shorter amount of time. Now you've got two options here. You've got two different paths. Which one do you choose? Well, it largely depends on what's important to you at that moment in time. So for example, if you're in a hurry, obviously you have a little amount of time. and you may choose to go to your school through the highway or the long route. That's okay, that's fine. However, if at the moment it's important to you that to save fuel and save possible CO2 emissions, and time is not that much of an issue, if that's important to you right now, then you will choose the inner city routes and you will take longer, but the distance will be overall lesser. So it depends on what are you prioritizing at that moment. So if you're prioritizing on time, in that case you will take the longer route. If you're prioritizing on reducing the cost of travel or the fuel cost, then you will take the inner city routes. So this is basic choice that we have to possibly make multiple occasions in our lives. But here's the interesting part. When I'm relaying traffic over the internet, and specifically through routers, the only priority that we follow, that these routers follow, is making sure that each and every packet reaches the destination in the shortest amount of time. Nothing is more important than time when network communications is involved. So when we see say the router will be choosing the best possible time, so the best possible path or the shortest possible path or the most efficient path between the source and the destination, we actually mean that it will be choosing the paths that requires the least amount of time for the packet to travel from the source and arrive at its destination. Now that path may also be the longest, that doesn't matter. But what's important is it is the shortest path. Now, how is it possible that if you're taking a longer path and still arriving at the destination faster? Well, it is quite possible that different interconnecting routers have different, you know, burdens on them. They may be at the moment processing many packets at the same time. So if a router is busy, if I'm a router and I have to decide on choosing between 3 different routers to forward this packet to, I will choose the packet which is the least busy right now. So it has the least amount of packets to process, and I'll forward it to that. It may be resulting in a longer path, but since I'm choosing the least amount of traffic on a particular router, that means my packet will have to wait the least amount of time, and it is possible that it will reach, and in fact, this is what happens, that packet will reach the destination in the shortest amount of time. So in network transmissions, the distance is not an issue, but the time is a very big factor, right? Any delay in data transmission will cause a cascading effect in all other further processing of that data. So if it's arriving late at the destination, that data will be processed later, and overall whatever application that is relying on that data will overall be delayed. So it is imperative that I make sure that that packet arrives at its destination in the shortest amount of time. Okay, so now let's look at the most advanced network that existed before internet became popular, and this is our public switch telephone network. Now, if we go back in the let's say late 1800s, Graham Bell made the telephone, invented the telephone, and it gained popularity in the next 100 and so years. And now, pretty soon, every household had a telephone network, a telephone in there, and communication through landline was actually pretty easy to do. It's a very common thing. How is it such a common thing? How did it become such a common thing? Because the network of our telephone or the telephone services had become an elaborate network over 100 or so years. Over the time, it became a very elaborate network. Now, this is basically the foundation of our internet services that we use today. So those of you who have ever experienced the use of a dial-up network are very familiar with this fact that if you do not have a telephone network at home, if you don't have telephone lines connected at home, you will not be able to access dial-up internet services. Prerequisite for accessing dial-up internet services was having an active telephone line at home. Now, why was that the case? Because our internet services was being forwarded to our homes through an existing network, which was a very advanced or established existing network, which is our public switch telephone network. Later on, when we have found other means, fiber optics, so on and so forth, we found other means, and we got routers and we got cellular cell towers. The internet transfer at homes had more options, and we were not solely relying on telephone lines. We were relying on other means of data transfer, much more higher speed data transfer at our homes. The structured support to the internet was initially provided by communication systems that were originally not created for computer networking. They were meant for voice communication, landline, telephonic conversation. Primary purpose of such a network was existing only for the purpose of telephonic conversations. Such type of system is the plain old telephone services, or its formal name, public switched telephone network. In its early stages of networking, the telephone only provided transmission of analog voice data. So basically, we were relying on electronic pulses to be traveling over these long distances. And we know that electronic currents are actually analog data, and this analog data was being received at our telephone devices, and we're not really using any sort of digital data. And there was no need for digital data because there was no computers involved. Computers require digital data, but voice communications and the way we were communicating was primarily based on analog data. For digital data to be communicated over computers, both sender side and receiver side were equipped with modems. Now, you may have heard of this term modem, and earlier applications of your internet services at home required modems to be installed. And modems essentially are the word modem is actually a combination of two words, modulator and demodulator. So basically, purpose of modulation and demodulation was creating digital data to analog for transmitting over long distances. And when a computer receives analog data, it is first passed through the demodulator, creating analog to digital versions so that the computer understands it. So when computers were starting to be involved in these standard communications, we had to figure out a way to make sure that the incoming signal is converted to digital, because computers do not understand analog data. For digital data, we had these devices involved. These are the modems. Now, when the computer is sending information out, of course, computer only processes analog data, digital data. But for our long distance data transmission, especially using telephone networks, I would require the data to be analog. For that, again, the demodulation part of these modems is required for sending data out back from digital to analog version. So at that time, when we were using the modems, the main purpose was converting analog data to digital for computer to understand, and then sending out digital data to analog for the computer to transmit data as an output. The internet services were provided via a dial-up network that provided modest speeds to end users, very slow speeds as compared to modern standards, very slow speeds. But these were dial-up networks. The reason they were sort of called dial-up network, because in a way you had to dial, make a proper phone call to connect to the internet. So it would really feel like that you're attempting to make a call to your internet service provider, and if it is possible, if the connection was established, only then you are allowed internet services. And during the use of internet services at that time, if, say for example, anyone made a call to you, they would receive a busy tone, because you are at the moment using telephone services. You are using your telephone line for transmitting internet, so that telephone line is not available for any other sort of voice communication whatsoever. So that was the internet services at that time. That's what we had. We worked with it, I worked with it, and this was the origin of internet services at that time. And since we were already relying on a very established network, which was the public switch telephone network, internet services through this mode picked up pace very quickly, because the existing infrastructure for telephone services was already in place, and we were just using this existing very established telephone service network to now provide internet at your home. Organizations could pay for a leased line that provided dedicated and permanently connected link at a guaranteed speed. So we've discussed the leased line concept in the event of banking systems when we were discussing wide area networks. So if, for example, I want to communicate different LANs and provide them as a WAN. So basically, if you remember what a WAN is, it's a wide area network, and in simple terms, it's a network of networks. So the communication between different LANs, different bank branches, as discussed before, could be carried out through a lease line. So basically, lease line means that you are contacting your service providers, and you are asking them to guarantee a dedicated line against some money, of course, some exchange, some on a purchase model. But the thing is, that line is dedicated for only your company's communications, so it allows for more, steady data transfer, higher speeds, so on and so forth. But of course, it costs you more. Now, public switch telephone networks have been upgraded to fiber optics, due to which data transfer is now carried out in digital form. The least service provided into the least services provided to our internet service providers allow for improved performance in both broadband network connection, in both traditional network access as well as through Wi-Fi hotspots where wireless access points are available. Now, we've discussed the purpose of wireless access points before, and what a wireless access point does, it connects a device which is basically wirelessly enabled to a wired network. So if I'm, for example, accessing internet through my, say, tablet, which only allows for Wi-Fi access, I may be connected to a wireless access point, and that wireless access point will have a LAN cable, Ethernet cable going out from it. And basically, what I'm doing is that I'm connecting my wireless device to a wired network, and this is the primary purpose of wireless access point. Now, with upgraded internet transfers and fiber optics, higher speed broadband internet has been possible. And you are capable of accessing that high speed broadband internet access through traditional methods such as Ethernet cabling, as well as through Wi-Fi services, which are more commonly used now, as because they are more convenient, of course, and they obviously offer better speeds as well. And this is basically how internet has transitioned. Initially, we just only had public switch telephone networks. Our transitions from public switch telephone networks to dial-up network happened in maybe the mid 90s. I think it was popular and in Pakistan at that point. And from dial-up networks, which was, of course, the basic version of internet services that offered to end users, the public. After that, and by the way, those dial-up networks, you had to pay for, just like a scratch card that we use from our cellular service or cell phones. You had to pay for those internet services through scratch cards as well. So you could purchase a scratch card from any market and use that scratch card code, log into that dial-up network, and use internet services. So as long as that scratch card is active, you can avail the internet services. After that, you could not. Okay, so this is how your internet services has progressed to what we're using right now. Okay, one thing I have to make sure here is that, is data being transferred digitally even if you're using fiber optics, or is it that I can also be transmitting data in analog form as well? Now, here's the thing. By this statement right here, it seems as if I'm using twisted pair copper cables, I am incapable of sending digital data. That's not the case. The thing is, digital data is also possible with twisted pairs cables as well. But the thing is, if I am using twisted pair or any cable on short distances, say within just one local area network, I can transfer data digitally. I don't have to transfer it in analog form. So within a short distance, when the cable is small, the data does not have to transfer over a long distance. I can choose to keep the data in its digital form, and any cable can transfer it from one computer to the next. But when I am relying data transfer over long distances, then waves have the capability of transferring over long distances. So in that case, in that particular context, data will have to be converted into analog form. But short distance data transfer, digital data can be handled perfectly. Okay, so now let's talk about cell phone networks. We've discussed this before, but basically it is an alternate method of internet access, and basically relies on the cellular services, or the cellular area in which a cellular phone operates. Now, basically what a cellular service, a cellular area, a cell phone, what does it mean is that it's a geographical area that is essentially divided into hexagonal shape, and this geographical area has a cell tower in between it, and those devices which operate within this geographical area are all cell phones. So if you are within the range of that central cell tower, you are capable of communicating with any other device. So basically what that means is that if you are within the range of that cell tower, you can avail cellular services. So as long as you're within that range, your cellular services will be available to you. Your cell phone or whatever smartphone your device you have will be able to it will be connected to a network. But if you move out of that cellular area, you will not be able to avail any sort of connectivity whatsoever. So a cellular phone is called a cellular phone primarily because it operates only within that cellular range, within the range of that cell tower. Now, modern cellular service internet service providers have also started to primarily just focus on internet services. Instead, apart from cellular services as well, they are also providing strictly internet services. Even now, if you go to your local mobile service provider, say for example Jazz, you can purchase a SIM that focuses only on data transfer. So basically what that means is that you can put that SIM in a device such as a dongle or a wingle, and that device will be capturing cell signals from the nearest cell tower and provide you with internet services. So what that means is that you are not only relying not only on today's day, you're not only solely relying on fiber optic cabling, but you can also rely on your cellular internet service providers for your internet access. So you've got so many options. You have so many different varieties of internet service providers. They can be fiber optic based and tier 1, tier 2, tier 3 based. Apart from that, they can also be cellular internet service providers that provide you cell services through a mobile or cellular cell tower. So this is the role of router, public switch transfer network, and the cell phone network that are active right now as we speak to provide internet services in different type of devices with great ease. By the way, with great ease. You're not linked to any more cables anymore. You're accessing these data through radio signals wirelessly. It's great convenience.